Good morning, students. This is Max class. Today we are going to learn the continuation of yesterday. Solving homogeneous equations. In homogeneous equation, we have two types of solution. One is trivial solution and another one is non-trivial solution. Trivial solution, that is unique solution, we will be getting 0, 0, 0. Non-trivial solution is infinitely many solutions, isn't it? These are the two we have, and yesterday we have did that sums. Today, you see, this balancing the chemical equations you might have learned in chemistry. So in mathematics, how we are going to balance the equation, we are going to learn. Say example 1.39. By using Gaussian elimination method, balance the chemical reaction equation. See, C5H8 plus O2 gives CO2 plus H2O. We know C is carbon, H is hydrogen and O is oxygen. So all the coefficients here we have to find out, isn't it? See, so I am taking let X1 C5H8 plus X2 O2 gives X3 CO2 plus X4 H2O. So X1, X2, X3 we have taken equation 1. Now we have to compare the carbon atoms on both sides, then hydrogen atom on both sides, then oxygen atom on both sides. See? Equating the atoms of carbon, hydrogen and oxygen respectively, we get, what are the things here? Carbon 5 is there, so 5x1 is equal to, here only one carbon atom, isn't it, equal to x3, which implies 5x1 minus x3 is equal to 0. Okay, this you can mark it as equation number 2. Then hydrogen atom 8. So 8x1 is equal to, then here we have 2 hydrogen atom, 2x4, which implies 8x1 minus 2x4 is equal to 0. Since 2 is common, I am just dividing by 2. So 4x1 minus x4 is equal to 0. This we can mark it as equation number 3. Then oxygen atom. Here we do not have, here 2 oxygen atoms there. 2x2 equal to, then right hand side 2. So 2x3, here 1 plus x4 is equal to 0. So which implies 2x2 minus 2x3 minus x4 is equal to 0. This is equation number 4. See, all the constant terms are 0. This is a homogeneous equation. Now, as our usual procedure, we have to find it out. So, first what we should do, we have to write the given equations in augmented matrix. Shall we write it? Zero is equal to, so we have 4 variables. If you want, we can write number of unknowns is equal to 4. x1, x2, x3, x4. So first equation x1 is there, x2 is not there, x3 minus 1, x4 is not there. Then this equation 4, x2, x3 is missing, x4 minus 1. Then here x1 is missing, 2 minus 2 minus 1. Is that clear? Okay. Now what we should do? we have to make this two values as 0. Already one value is there with 0. So this position we have to make it as 0. Okay, see, first we should make this two position as 0, isn't it? Already here we have 0, here we have 4. Both different numbers, isn't it? That's why I am changing R2 going to change as 5 into R2 minus 4 into R1. So 5 into 4 is 20. The same way 4 into 5 is 20. So it will become 0. Since both numbers is there, we can write it in the side. 5 into R2. So 20, 0, 0, minus 5. Then minus 4 into R1. Minus 5 into 4, 20, 0, minus into minus plus 4, 0. So when we add 0, 0, 4, minus 5. R3 there is no change. Now we can see that this two position we have made it 0, isn't it? Next actually this position we have to make it 0. But here we have 0. So what we can do? Interchange these two rows. Okay. See, R2 is interchanged with R3. Now almost we have did. Okay. So 0, 0, 4, minus 5. Now we can write the equivalent form because here 2 is there. This place anyway we cannot make it as 0. Isn't it? So what we can do? Equivalent or a rank of A equal to rank of A comma 0 is equal to number of non-zero row is 3. But our number of unknown is 4, which is less than 4, isn't it? Therefore, the system has infinitely many solutions. So anyway, first we can write the equivalent equations are the first one 5x1, x2 is not there, x3 minus x3 is equal to 0. This is new equation. Already till equation 4 is given, so I am writing it as 5. The next 2x2 minus 2x3 minus x4 is equal to 0. This is equation number 6. Then last third is 4x3 minus 5x4 is equal to 0. This is equation number 7. So anyway, 3 equations we have to put substitution, isn't it? Because one is less than. So put x4 is equal to t, comma, t belongs to any real number. So equation 7 implies 4x3 minus 5t is equal to 0, or 4x3 is equal to 5t, or x3 is equal to 5t by 4. So x4 we know, x3 we have got it. Now equation number 6 implies 2x2 minus 2 into x3, that is 5t by 4, minus x4, that is minus t is equal to 0. No need to cancel, or you can just cancel it, no issue. So 2x2 minus 5t by 2 minus t is equal to 0. So 2x2, take LCM, 2 will be the LCM, minus 5t minus no number, so we have to multiply by 2, equal to 0. So 2x2 minus 7t by 2 is equal to 0, which implies 2x2 is equal to 7t divided by 2, or x2 is equal to 7t divided by 2 into 2 is 4. So we have got the value of x2 also. Now these all we have to substitute in equation number 5. 5x1 minus x3. The value of x3 is 5t by 4. Shall we substitute? See, 5x1 minus 5t by 4 equal to 0, or 5x1 is equal to 5t by 4 or x1 is equal to 5t by 4 into 5. This 5 and 5 will get cancelled. So we have got it x1 is equal to t by 4. See, x1 equal to t by 4, x2 is equal to 7t by 4, x3 is equal to 5t by 4 and x4 is equal to t. We know that t belongs to real number. But we have to give any one of the values, isn't it? For we have many values, at least one value we have to give. Say, since all the denominators are with 4, I am taking t is equal to 4. If I take t equal to 1, we will get it in fraction. T equal to 2 means also we will get in fraction. So, I am take t is equal to 4. Then, x1 is equal to 1. x2 is equal to 7. x3 is equal to 5. And x4 is equal to 4. Right? Therefore, the balanced equation is x1, so that is C5H8 plus x2O2, that is 7O2, gives x3CO2, x3 5CO2 plus x4 into H2O, that is 4H2O. Now you check it here, carbon atom 5, here also 5 into 1 is 5. Now hydrogen, here we have 8, here you see 4 into 2, 8. Oxygen, 7 into 2, 14 in left hand side. Here you see 5 into 2, 10 plus 4 into 1 is 4. 10 plus 4, 14. So it's understood. The given equation, we have got the answers correct. Do you all understand this? Shall we move to the next problem? See the next example, 1.40. Last example in this chapter. If the system of equations, see 3 equations are given, has a non-trivial solution. This given equation has non-trivial solution and P not equal to A, Q not equal to B, R not equal to C. Prove that P by Q by R by is equal to 2. Why they gave P not equal to A? If P is equal to A, what happens? This denominator will become 0. That is why they have given P not equal to A, Q not equal to B and R is not equal to C. See the solution. Given the system has a non-trivial solution. Yesterday we learned, isn't it? If it is a non-trivial solution, then the determinant of the coefficient matrix should be 0. The determinant of the coefficient matrix should be 0. So using the condition, we are going to prove this. Okay. See, this is what. Determinant PBZ, AQZ, ABR equal to 0. I have written all the coefficients. Now, see, these two A is there. I am just going to subtract. R2 is going to change as R2 minus R1. The same way, R3 is also going to change as R3 minus R1. So, first row, there is no change. See, this is A minus P, Q minus B, C minus C is 0. Again, A minus P, B minus B is 0 and this is R minus C equal to 0. See, actually in our answer, we need P minus A, not A minus P. So, P, here I am taking the minus outside, so we may get P minus A. Here also minus, this is P minus A. Here B, Q minus B, 0. C, 0 or minus C is equal to 0. So, from this row, I am going to take P minus A outside. Okay. And from this row, Q minus B. And from this row, R minus C. See, from this column, when we take P minus A, there we have no P minus A. So, I have to divide P by P minus A. So, in this, minus 1, minus 1. And as I said, from this column we have taken q minus b. So what will happen? B by q minus b. Here 1, 0. It doesn't matter. And from here, in this column we have taken r minus c. Here we do not have. So what we should do? C by r minus c, 0, 1 is equal to 0. Is that clear? Okay. Now, see, given P not equal to A, Q not equal to B and R not equal to C, isn't it? So, this all values cannot be equal to 0. So, only possibility is this determinant alone can be equal to 0. P by P minus A, B by Q minus B, C by R minus C, minus 1, 1, 0, minus 1, 0, 1 is equal to 0. Now we have to simplify this in our ordinary determinant and we can do it. See, first value I am writing P by P minus A into, leaving this row and column, 1 minus 1, 1, minus 0 into 0 is 0. Minus B by Q minus B into, leaving this row and column, minus 1 into 1, minus 1, minus 1 into 0 is 0. The next one we take plus, isn't it? Plus C by or minus C into, leave this row and column, 0 minus 1 into 1 is minus 1, since already we have a minus here, plus 1 is equal to 0. See, very simple. P by P minus A, this minus into minus, plus B by Q minus B, plus C by or minus C is equal to 0. But actual our answer we need to prove is P by P minus A, Q by Q minus B, plus R by R minus C. But here we have B, isn't it? And here also we need equal to 2. So what we can do is, here Q we need. So add 1 Q and subtract 1 Q. Here also add 1 R, subtract 1 R. Then we will get the answer. See, P by P minus A, Q minus Q plus B. Value did not change, isn't it? The same way here R. Say this one modification I am going to do. This Q, take the minus out. So I may get Q, this from this I have taken the minus out, minus B by Q minus B. Plus R, the same way take the minus out, then it will become R minus C by R minus C is equal to 0. See, minus R, minus into minus plus C. Value did not change, isn't it? Now I am going to separate each term. That is Q by Q minus B minus Q minus B by Q minus B plus R by R minus C minus R minus C by R minus C is equal to 0. See, this both will get cancelled. Then P by P minus A plus Q by Q minus B minus 1 plus R by R minus C minus 1 is equal to 0. Or P by P minus A plus Q by Q minus B plus R by R minus C minus 1 that is minus 2 is equal to 0. Now take this to next side. P by P minus A plus Q by Q minus B plus R by R minus C is equal to 2. Hence, prove. See, this is what we need to prove. Do you all understand this? Take the condition that the determinant of the coefficient matrix is 0. As possible as you simplify, then use the ordinary determinant to prove, to bring our answer. Okay. Now we can do the exercise problems. Exercise, that's 1.7. Second problem. See, determine the value of lambda for which the following system of equations, 3 equations is given with 3 unknown x, y, z has subdivision 1 unique solution, subdivision 2 a non-trivial solution. Non-trivial solution, what is the meaning of that? Infinitely many solution. So this type we have did in the previous exercise also. There with the 3 conditions we might have learned, because there no solution is also there. But Here in homogeneous equation, there is no solution, isn't it? That is why unique solution. Unique solution, when we will get it, both the rank should be equal to the number of unknowns. And if it is less than the number of unknown, we will get the non-trivial solution. Shall we do it? Okay, listen. 1, 1, 3, 0, 4, 3, lambda 0, 2, 1, 2, 0. Since the unknown value, this lambda is in the second row, I am just interchanging that R2 and R3, okay? So, to make it simpler, that's all. 1, 1, 3, 0, 2, 1, 2, 0, 4, 3, lambda 0. Now, as our usual procedure, below this first entry, these two values, we have to make it as 0. There one only is there, isn't it? 2 minus 2 means it will become 0. So, R2 is going to change as R2 minus 2 into R1. And here 4 is there. 4 minus 4 means we will get 0. So, R3 is going to change as R3 minus 4 into R1. So, shall we do it? See, first row there is no change here. 2 minus 2, 0. 1 minus 2, minus 1. 2, when we multiply by 2 here, 6, isn't it? 2 minus 6, minus 4. Here, 0. 4 minus 4, 0. 3 minus 4, minus 1. Then 4 into 3, that is 12, isn't it? That's lambda minus 12, and here 0. Now the next place is to make this as 0, isn't it? That is also simple only. R3 is going to change as R3 minus R2. So 1, 1, 3, 0, 0, minus 1, minus 4, 0, 0. Minus 1, minus of minus 1 is plus 1, 0. See here, lambda minus 12, minus of minus 4. That is lambda minus 12 plus 4. So we may get lambda minus 8. Here 0. More than this we cannot simplify, isn't it? So we can stop with this step. Now case 1, a unique solution. Unique solution means, what is the meaning? Both the rank should be equal to the number of unknown. So here sure we should get value. It should not become 0. So if lambda minus 8 is not equal to 0 or lambda not equal to 8, then what happens? Rank of A is equal to, rank of A bar 0 is equal to 3. The number of unknown, isn't it? Hence, the system is consistent and has unique solution. Is that clear? Then case 2. That is a non-trivial solution. Non-trivial means the rank should be less than. That means this value it should become 0. That is, if lambda minus 8 equal to 0, that is lambda equal to 8, then it is understood rank of A equal to rank of A bar 0 is equal to 2, which is less than 3. Therefore, the system is consistent and has infinitely many solutions, isn't it? And has many solutions and has a non-trivial solution. This is easy, isn't it? But important problem. Okay. So by this, almost we have completed. We will try to do one more problem if we have the time. Okay. See exercise, that same exercise, third problem. By using Gaussian elimination method, balance the chemical reaction equation. Already we did one example problem, isn't it? So first we can take let x1 C2H6 plus X2O2 gives x3 H2O plus x4 CO2. Is that clear? Then what we should do? The number of unknown you can write. For that, equate, isn't it? Equate the coefficients. Okay, equate the atoms of carbon, hydrogen and oxygen respectively. We get carbon first, 2x1. Here, okay, last we have equal to x4. So, which implies 2x1 minus x4 is equal to 0. I am keeping it as equation number 1. Then hydrogen. 6 atoms we have. 6x1. Here we have equal to 2x3, which implies, you see, 6x1 minus 2x3 is equal to 0. Since 2 is common, we can divide by 2. 3x1 minus x3 is equal to 0. This is equation number 2. Now coming to oxygen atom, here we do not have here 2. 2x2 is equal to x3. Here we have 2, that is plus 2. x4 is equal, x4, which implies 2x2 minus x3 minus 2x4 is equal to 0. This is equation number 3. So from this we understood the number of unknowns is equal to 4. So Gaussian elimination method we should do. So first we have to write the augmented matrix. That is 2, x2 is not there, x3 is not there, x1, x4 minus 1, 0. Then the second equation 3, 0, minus 1, 0. Here x1 is not there, 2, minus 1, minus 2, 0. Is that clear? Anyway, first our work is to make this value as 0, isn't it? In that row echelon form to bring it. So I am writing R2 is going to change us. Both we have to multiply, isn't it? Here we have to multiply by 2 and here we have to multiply by 3. So 2R2 minus 3R1. So 2, 0, 0 minus 1, 0. Here this anyway it will become 0, 0. See here we have to multiply by 2. Minus 2, minus there 0 only is there. So minus 2. 0 minus, we are multiplying by minus 3. So plus 3. Now the next work to make this value as 0, isn't it? But here we cannot make this as 0. So we can interchange R2 and R3. See, just I have interchanged. Now anyway more than this we cannot simplify. Now from this it is understood rank of A is equal to rank of A bar 0 is equal to how much? Number of non-zero row is 3. But our number of unknown is 4. So this is less than 4. So I can write the system is consistent. It has solution. But that is infinitely many solution. So and has infinitely many solution. Or even you can write non-trivial solutions. Okay. Many solutions. So write the equivalent equation. That is 2x1 minus x4 is equal to 0. Equation number 4. Then 2x2 minus x3 minus 2x4 is equal to 0. That's equation number 5. Then minus 2x3 minus 3x4 is equal to 0. This is equation number 6. What we should do? As usual, this is plus, isn't it? Plus. So put x4 is equal to t, comma t belongs to the real number. So equation 6 implies 2x3 plus 3t is equal to 0 or minus 2x3 is equal to minus 3t. Minus and minus will get cancelled, isn't it? So we have got it x3 is equal to 3t by 2. Isn't it? Now shall we substitute in equation 5? So equation 5 implies 2x2 minus x3, that is 3t by 2, minus 2x4, x4 is t, is equal to 0. So 2x2 minus, take LCM, LCM is 2, 3t minus 2 into 2, 4t is equal to 0. Or 2x2 minus 3t minus 4t minus 7t by 2 is equal to 0. Or 2x2 is equal to 7t by 2. Or x2 is equal to 7t by, this 2 into 2 is 4. Now almost all the values we should give here. But here 2x1 minus x4 only is there. x4 the value is, see, 2x1 minus t equal to 0 or 2x1 is equal to t. x1 is equal to t by 2. So we have got it, x1 equal to t by 2, comma, x2 is equal to 7t by 4, x3 is equal to 3t by 2, comma, x4 is equal to t, comma, t belongs to R. Any value, isn't it? In the example problem, there all the denominators were 4. So we took 4, isn't it? To make all the values as an integer. See here, 2 is there as well as 4 is there. The highest value is 4, isn't it? So we can take t is equal to 4. In order to, if we take 2, here again we will get 2. Only 2 and 2 will get cancelled. So again the possibility is there to get 2 in the denominator. That is why we are taking t is equal to 4. So which implies x1 equal to 4 by 2, comma, x2 is equal to 7. Isn't it? 4 and 4 will get cancelled. Here x3 is equal to 3 into 4 by 2, comma, x4 is equal to 4. Here also if you want you write 4 by 4. See, 2. 1 2 is 2, 2 2s are 4. Therefore, x1 equal to 2, comma, x2 is equal to 7, x3 is equal to 3 into 2, 6 and x4 is equal to 4. Therefore, the balanced equation is two C2H6 plus S2, that is 7O2, gives X3 6H2O plus X4, that is 4CO2. Now check it, 2 into 2 4 carbon atom. Hydrogen 6 into 2 12, here also 6 into 2 12. Oxygen 7 into 2 14. Here they have 6, 4 into 2 8. 8 plus 6 14. So this is balanced equation. Is that clear? See the homework part. The first problem is homework for you. Solve the following system of homogeneous equation. See, 3 unknown is there. Here you may get non-trivial solution. That's infinitely many solution. If you take it as t, you may get x equal to minus t, y is equal to minus 2t and z is equal to t, comma, t belongs to R. And here for the second subdivision, trivial solution. Trivial solution means x equal to 0, comma, y equal to 0, comma, z is equal to 0. Is that clear? See, by this our first chapter is completed. So now your work is to study and keep it thorough this chapter. Okay. So Monday we will be learning and the next chapter, that is a new interesting topic. Okay. Thank you students. See you. Bye-bye.